Studying stars and galaxies is studying everything that we can see. Hi, I'm David Rosario. I'm a researcher here at the Center for Extragalactic Astronomy at Durham University. I study observational astronomy, which means that I use big telescopes and I use computational resources to try to understand objects in the universe that we can observe, how they change, how they relate to each other. I'm very proud to be able to use some of the biggest telescopes in the world. If it's one reason I do astronomy, we are really sort of pushing the limits in terms of technology, and to be close to that is a real joy. Astronomy is driven by small numbers of people working together on a particular topic in detail. So different institutions throughout the world have different areas of expertise. We don't have the big picture until we all work together. We really need this international focus to get it done as well as it can be. It's a process of science is to redo an experiment. And often it does happen that some amount of data was observed in a certain way or studied in a certain way. Another group looks at it a little differently, and then there's often some debate about what's the right way of interpreting it. And that actually sets up these proposals for new data. Because you might say, well, this is not going to work. Let's take some more data from a different angle, try to understand it a little more. Everything that we need to learn about the universe comes from looking at what I call touchable matter. We call it baryonic matter. It's matter made up of protons and neutrons and electrons. And so stars and galaxies are the two elements of the universe, essentially, within which you find a lot of this baryonic matter, this touchable matter. The expansion of the universe is one of the first observations, in some sense, of modern astronomy. When people identified that galaxies, which are huge conglomerations of stars, were moving away from us, they thought something interesting was happening. This is stuff that Edwin Hubble did. The person whose the Hubble Space Telescope is named after, one of the great astronomers of the 20th century. And he also found out that galaxies that are further away from us move away faster. Now, this was surprising, because if everything is moving away from you, you'd say, well, I'm in the center and everything's just expanding away from me. But because things that are further away are moving away faster, that gives a clue that it's not just us. Things are moving away from every other thing. Every galaxy is moving away from every other galaxy because space itself is expanding. And so the fact that there is this sort of relationship between distance and speed is one of the fundamental bits of evidence for the expansion of the universe. To me, one of the most interesting aspects about understanding stars and galaxies and how they form and evolve, how they change over time since the beginning of the universe, comes down to something rather mundane. It's gas. It turns out that stars are formed of gas, right? And galaxies are formed of stars. Most of the touchable matter, this baryonic matter in the universe, is in the form of gas. And how that gas flows into galaxies and ultimately gets down to stars and then planets and us is a crucial element of studying galaxy formation evolution. It's one of the key questions for us. So understanding how this gas gets in and gets out of galaxies is a big driver of a lot of science, including my own. So I study how giant black holes in the centers of galaxies relate to the gas in galaxies, how they affect star formation, how they grow themselves. And what black holes can do very beautifully is actually heat up a lot of gas and blow it out. Fundamentally, the most important thing for me, at least in astronomy, is where we came from. It's a deep connection to humanity. We are made up of elements which were formed in stars, and much of that happened in the early universe. So it's only now that we have been able to study the early universe in detail. It's very hard to do. These things are very far away, they're very faint, and you need these big telescopes and you need a lot of interesting facilities to study the early universe. To me, that's the big new thing. Looking at the first stars that formed in a pristine universe where there were no heavy elements, no carbon, no nitrogen, none of these complex things from which you and I are made. Those stars made those elements. And looking at those stars, the first stars that produced the things we're made of, is really interesting. Things like the James Webb Space Telescope are designed specifically to study this early universe. I think there's going to be fantastic stuff happening in early universe science in the next 10, 15, 20 years. Exactly when people who are now in school are going to be wanting to become astronomers. So think about doing early universe astronomy. It'd be a good way to go.